So we have established that we need good randomness, we need entropy in order to do cryptography. But how do we do that? Well, let's implement a entropy generator. Most likely you'll just go on the internet, look up, maybe there's a get entropy function already implemented somewhere, and then use that. Well, in order to really understand something, I would suggest to really write the primitive of getting entropy ourselves, because somewhere it needs to be implemented, right? In the standard library or in the operating system, somewhere this entropy generation has to be implemented in code. Go further. Okay. Of course, we can always do this. Can always ask the user to input randomness. This way we as developers don't have to do anything. Just, okay, choose a truly random password with a lot of different cases and a number and a character and a special character. Yeah. We can always use the user as a random number generator, but maybe we don't want to use that kind of randomness for our AES key. So now, maybe first think about what would you do if you would have to implement from scratch, without any libraries, an entropy generation mechanism. Well, as I said, entropy is uncertainty. Entropy means something is not predictable. Now, if you think about it, a computer is a deterministic machine. So every state transitions in another state, and the state you're currently in, you know the exact reason why you're in that state, because of the predecessing state. So the problem here is that in a deterministic machine there can't be randomness, because the computer just does not know how to behave randomly. So how would you implement it with if, else, and for loops and whatnot you have in your language? Well, you can't really, but you can do something like this. You can maybe get values that are hopefully random enough. You could get some high-resolution CPU clock, for example, RDTSC register maybe. You can get information like the current process ID, something like that. Multiplied by 13 maybe, because 13 is a prime number and prime numbers are always good, I heard. And then store it in the entropy. Well, these values here are still not random, but they somewhat depend on the user, and maybe we can use the user or other events like high-resolution clocks to generate numbers that are hopefully random enough so that an attacker can't predict them. And that's actually what crypto libraries do as a fallback option if the operating system can't provide randomness or entropy.